welcome. Let's start with exercise 12.2. The third question here you have. A statue stands on the top of a 2-meter tall pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degrees. From the same point, the angle of elevation of the top of the pedestal is 45 degrees. Find the height of the statue. Now here, let's make a diagram according to the given data. You have a pedestal. You have a 2-meter tall pedestal with us. So this pedestal is with 2 meters of height. And next, a statue stands on the top of the pedestal. So here you have a statue. Okay, a statue which stands on the top of the pedestal. Okay, next, the angle of elevation of the top of the statue is 60 degrees. So from a point on the ground, the angle of elevation of the top of the statue is 60 degrees. So as we can make angle of elevation as 60 degrees as the angle of elevation is 60 degrees. So okay, the angle of elevation from the statue to the ground is 60 degrees. So here as we can write like 60 degrees over here. Now from the same point, the angle of elevation of the top of the pedestal is 45 degrees. So the angle of elevation, so from this same point, the angle of elevation from the pedestal to this point is 45 degrees. As let's make a picture according to this. So we can make like this. Okay, here you have 45 degrees. Then now find the height of the statue. So we need to find the height of the statue. Let this point be A. Let this point be B. Let this be C and this be. Now here we need to find the height of AB. As I need to find the height of the AB. So let height of the statue be X. Let height of the statue be X. Now here, firstly, if you just observe, you can look into two triangles in this given triangle, in the given right angle triangle, where triangle A, DC will be the first right angle triangle, and the second one triangle BDC. Then BDC. Now here I have a value for a side in triangle BDC, but I don't have a value for a given side in triangle ADC. Okay, now by using this BDC, let's find the value of DC. Okay, by finding the value of DC, we can further find the value of AB. So now let's consider triangle BDC. So let's make like solution over here. Okay, so as here I can write like in triangle BDC. In triangle BDC. Okay, in triangle BDC, I need the value of DC, as I can consider like opposite side by adjacent side. Which trigonometric ratio relates opposite by adjacent? Yeah, as we know, tan theta and cot theta, they both relate opposite by adjacent side. So we can either take tan or cot, but here I would like to take tan. So let's consider tan theta, where tan 45 degrees equals to opposite side to the angle D is BC. you have DC, and opposite to the angle D, you have BC. Now where tan 45 degree value will be 1 equals to BC, as here you have 2 meters, and DC, let DC be DC. As we haven't any values for DC, as I have considered BC as just DC. Now here by cross multiplication again, as we get what? 2 into 1 gives 2, where 2 equals to DC. Done, where 2 meters as we get, right? Okay, but DC equals to 2 meters. Got? As we can write like 2 meters. Where DC value we got as 2 meters. Now here we got the DC value. Thus we can consider this triangle by triangle ADC. By considering this triangle, we can find AB value. Also, firstly, by finding AC value, whereas we know where AC minus BC equals to AB. Okay. So firstly, if we find the AC value, where AC so this will be the AC value. Okay, by finding this value, where AC minus BC gives what? AB value. Okay. Now here let me write down like let's consider in triangle ADC. Done. In triangle ADC. So in triangle ADC, where again consider opposite by adjacent side. Okay, as here I need the value of side, I don't need the value of hypotenuse. So just consider the opposite side by adjacent side. So as adjacent side we have value for it. So now again take tan 60 degree equals to opposite to the angle D, where this will be 60 degrees. Opposite to the angle D, you have AC by adjacent to the angle D, you have what? DC. Right? Clear till here? Now where tan 60 degree value is √3 equals to AC. AC value over there, where AB plus BC equals to AC by DC as 2 meters. DC as 2 meters. Now here we can write like √3 equals to again AB value as x plus BC value as what? 2 meters by 2. Okay. Now here 2 into √3, 2 into √3 gives what? 2 √3. 2 into √3 gives what? 2 into √3 as well, equals to x plus 2. I need the value of x, where x equals to AB. I need the value of x. Now by transposing this plus 2, okay, by taking this plus 2 to the other side, not transposing but taking this plus 2 to the other side, this makes what? Minus 2. Plus symbol turns into minus if we carry this to the other side, as we get like √2 √3 minus 2 equals to x. As I got the x value, but 2 √3 minus 2. Now by simplifying this, as I can write like take 2 as common. Okay, here you have just take 2 as common. 2 into √3 minus 1, where 2 into √3 gives what? 2 √3. 2 into minus 1 gives what? Minus 2. We got this equation over here. So I have just written this equation like this. Okay. Now this is equals to x. Let this be x. Now okay, this equation is equals to x. Now √3 minus 1. We know the √3 value. √3 value we know that 1.732 minus 1. 1.732 minus 1, which gives what? 0.732. Right? Where 2 into 0.732. 2 into 0.732 becomes 14. 3, 6, 2 is 4. Where decimal point before 3 numbers. So here we get like 1.464, where this is equals to x, this is equals to x, this is also equals to x. Thus we got the x value where x equals to 1.464 meters. Sorry, x equals to 1.464 meters. Okay, that's the height of the statue. Height of the statue is 1.464 meters. As here we got the value of statue, where AC value, if we add 1.464 plus 2 meters, we get AC value. But the required question they asked here is we need to find the statue value. Thus the height of the statue is 1.464 meters. Now let's conclude this as therefore. So therefore the height of the statue is 1.464 meters.